Good morning, everyone. Now that we've covered the basics of vectors and some of the operations, addition, subtraction, and scalar multiplication, we can start doing some applications. So we're going to go through a few different examples of some things you can do with vectors. So example one, a plane is taking off from Toronto and it flies 1,000 kilometers due south. Then it adjusts its heading and flies an additional 800 kilometers south 15 degrees west. How far from Toronto is the plane now? Okay, so first thing, right, we're going to want to set up a diagram. So we'll start with 1,000 kilometers due south. Now we've got that, we'll add on the second part. So that would go on the tip of the 1,000 kilometers. So I'm going to move my page down here a bit so I have lots of room. Okay. Now we'll just draw on my resultant, right? What I'm looking for is kind of the overall distance from Toronto. So they're already lined up tip to tail. So I'll just add the resultant onto the diagram. Okay. The last thing is I haven't really incorporated the angle yet. So let's add the angle to our diagram. So the 15 degrees, right, if I continued my south line, it's that little angle in there. So now that I have all that set up, it's time to figure out the resultant. So I have a triangle. I've got two sides. I need the third side. Okay, I currently have no angles, but as you've probably noticed here, right, I have the 15, which means I do know this angle inside the triangle. So let's just start giving things some labels. So we can call this say triangle A, B, and C. And I can see that because it's supplementary angles, this angle C in here is going to be whatever 180 take away 115, sorry, 180 take away 15 degrees is. And that I believe is 165. So now that's all set. I can use cosine law to get my value for C. Okay, so we'll set up cosine law in terms of C. So C squared equals my other two sides, 800 squared plus 1,000 squared minus 2 times 800 times 1,000 cos of 165. Okay, I apologize for the writing. It's not super easy to write on my laptop. Okay, so we've done cosine laws before, so I would assume at this point we can all work that through. And we end up getting for C about, if we round it off, we get 1784.8 approximately, okay, in terms of the kilometers. Okay, so now I know how far away the plane is. Okay, it might also be useful to know in what direction. Okay, so what angle is that? So that means I'm going to have to go back to my triangle and find the angle at the top, the angle A. Okay, so again, I guess it's not technically asked that in the question, right? It just says how far. Okay, but we may as well practice that step. Okay, if I want angle A now, I have enough information to use sine law, and I can get angle A. Okay, so we have sine of A over 800 equals sine of C, so sine of 165 over newly found side there, 1784.8. Okay, again, at this point, confident we all know how to run that through. So when we get down to it, the value of A is 6.7 degrees. Okay. So to wrap that all up, okay, so we're 1,784 kilometers, or 0.8 kilometers from Toronto, bearing south 6.7 degrees west. So the plane is okay, so 1784.8 kilometers south 6.7 west. Okay, there we go. Okay, on to example 2. A boat sets a heading of north 25 east at a speed of 30 knots. There is a current of 5 knots from a bearing of south 45 east. What is the actual bearing of the boat? Okay, so we have the intended course, and we have a push from the current. Okay, which way does this actually go? So again, we'll start with the diagram. And because I'm not going due south this time, I'm actually going to set up a little axis first so we can see what we're doing here. Okay, so we have north 25 east, so it'll be somewhere in here at a speed of 30 knots. Okay, and then for the second part, right, there's a current of 5 knots from a bearing of south 45 east. So south 45 east is down here, okay, but it's coming from there. So the direction of this is actually towards the center, okay, not the other way around. Okay, again, because it says it's from there. So we'll give that a 5. Okay, now, so there's a couple ways I can maneuver this around. Okay, just so they're both at the center, I'm going to push this up. Okay, so there's nothing wrong with pushing this here. So now I have them set up as tail to tail. So you might recall the other method we can use to add things together is to finish the parallelogram here and then use that to get my resultant. So I'm just going to copy this one up here. And my resultant is going to come from the center up to there. Okay. All right, so yeah, it is relocated. I'm up here now. So in order to figure this out, okay, that's also 5. So I'm kind of in the same situation I was in the last problem. Right, I've got the 2 side lengths here. Okay, if I knew the angle in this corner, okay, I would be able to get the next part. Okay, unfortunately, it's not very clear from the diagram here. We need to do some adding of angles. So I'm going to make this a bit bigger so we can really see what's going on. Okay. So to help establish what's happening here, okay, we'll start adding the angles we knew. So this was north, I think 25 east. Okay, so that one's 25. Okay, for the south 45, okay, I've kind of lost my direction of it here. So I'm just going to redraw the axis, okay, at this corner. Okay, so I knew it was 45 degrees, right? It's right up the middle. So that means that this piece right here and this one over here, same, that is going to be 45 degrees in there. Okay, so now I need this piece in here, right? Where am I going to get that from? Okay, so this is where all those angle properties and things we reviewed comes in handy. Okay, I have a Z pattern here, right? If I go this way, right? Because this is the north-south line. This is also a north-south line, so they are parallel to each other. Okay, so that means that this little angle in here, okay, and I'll get rid of all this highlighter mess in a minute. Okay, this angle on this side is also 25 degrees, okay, due to the properties of parallel lines. So let's copy that in here. Okay, so this angle in here is 25, which makes this angle in here 90 minus 25. It should be 65, I think. Okay, so this angle in here is going to be 65. Okay, so now I have this entire angle in the corner. 45 plus 65 is 110, and the two sides, and I can now use cosine law to get what I need. Okay. So again, this time we're going to set up with cosine law. So it's going to be basically the same thing we had before. Right? I have c squared equals 30 squared plus 5 squared minus 2 times 30 times 5 cos of 110. Okay, again, I trust that we know how to run that through. So C is about 32.1. No, yeah, 32.1. Okay, again, now we need to figure out the bearing. Okay, the angle I actually want is this tiny angle in here, okay, but it is outside the triangle. So we will use the information I have in the triangle to get this angle in here. Okay, and then I can use that to backtrack to this angle out here. Okay. And again, I think this is different from the online notes. I think I used a slightly different setup for the triangle there. So I think I had made this side C. So there's my C. We'll call again A, B, and C. So now I'm looking for angle B in the bottom of the triangle. So we have sine of B over 5 equals sine of 110 over 32.1. So B is going to be equal to about 8.4. Okay, so my little gap angle is 8.4. So the angle I want up in here, yellow, I'll show up a little bit. Okay, so to get that one, I would just have to start with my 25 degrees, right, and subtract the 8.4. Okay, and so that is equal to about 16.6. Okay, so my concluding statement, the actual bearing of the boat, actual bearing is 32.1 knots, and the direction is north, 16.6 degrees east. Okay, and there we are. Final example is a little bit of a physics problem involving tension. A bird cage with a mass of 5 kilos hangs from the ceiling, suspended from 2 wires. Each wire makes an angle of 75 degrees with the ceiling. What is the tension in each wire? So again, we'll start with a diagram to get an idea of what's going on here. So I have my little bird cage. Bring out the fine artist in you, like I'm trying to do right now. Okay, it's suspended from 2 wires. So one going this way, one going this way. Okay, each of those wires makes a 75-degree angle with the ceiling. So that is 75, and that is 75. What is the tension in each wire? Okay, so for those of you who haven't taken the physics part, okay, tension is a force. So we need to have this all written in terms of forces. Okay, so to start with the mass, right, we were given it was a mass of 5 kilograms. That's there. Okay, but again, I want to deal with forces, so that means I have to get the weight of the object instead. Okay, so I need weight. Okay, so you might recall from one of the very early homework problems we had, okay, the way you calculate the weight of something is basically the force that gives you that feeling of weight is mass times acceleration. Okay, the mass of the object is 5 kilos. Okay, and the acceleration due to gravity is 9.8 meters per second squared. So we just have to multiply those two things together. Okay, and that gives us 49 newtons down. Okay, so I have a force of 49 pointing down. Okay, so now we're going to redraw our diagram to kind of show just the forces at work. Okay, because the idea is, right, these two tensions that are pulling up on the birdcage have to balance the force of gravity pulling down on the birdcage. Okay, or basically the net effect is 0, so they don't move. So the way we structure this is I'm going to start again with that force of gravity. Right, so I have 49 newtons pointing straight down. Okay, so I'm going to pick one of the wires, doesn't really matter here, right? One points away, the other one points the other way, and together they should cancel out, right? If I do this vector plus this vector plus this vector, I'm back where I'm started, I have 0. Okay. Next thing we need to do is add in our angles. So again, I'm going to draw on the horizontal there because they were with reference to the ceiling. So I know that this angle is supposed to be 75, and I know that this angle up here is supposed to be 75. Now, again, by the Z pattern, right, if I go back and forth this way, 1, 2, 3, that tells me the other angle in here, okay, is also 75 right there. So we'll add that on. That is also 75. Okay, so I have a combined angle of 150 in the middle. And that's enough to figure out what I am missing here. Okay. I need to, I guess I can add that right now. That allows me to find the other angles too. Okay, again, that was 75 at the top, right? So this little angle in here must be 15 degrees. And similarly, the one at the bottom must also be 15 degrees. Okay. And now I can just use sine law to find the missing things. Okay. Also note it's isosceles, right? All these angles in here are the same. So once I found one tension, I really found them both. Okay. So maybe I'll label this tension 1 up here. So to solve for tension 1, okay, so it's sine law. So my tension over the sine of 15 degrees, okay, equals 49 newtons over the sine of 150 degrees. Okay, so tension 1 is equal to 25.4 approximately. Okay, and then similarly, the other tension is also going to be 25.4 because it happens to be isosceles. Okay, so therefore, each wire has a tension of 25.4 newtons. Okay, and that's pretty much done. Okay,
Right? If the two wires have different angles at the ceiling, this would have been a little more complicated. Okay, but it's the same idea, right? Draw what you know, put the angles where they exist in the original diagram, and then use that to figure out what is left. Okay. Okay, so that's it for now. Just the practice work. So on page 343, again, there's 8 questions that you can work on to practice setting up these diagrams and solving for missing information. Right. Thanks for watching. Have a wonderful rest of the day, and I will see you tomorrow.